Good morning, everyone. Today I will be taking you through lecture 7, which is array. So last week we did lecture 6, whereby we have been talking about loops, understanding different types of loops, advantages of loops, while loop, for loop, and many more. So today we will be on arrays. So we have to understand how arrays are used, understand how arrays occupy the computer memory, how to store and retrieve items inside an array. So we will do a flowchart to demonstrate flowchart and the pseudocode to demonstrate how arrays are being used. At the end of this lecture, I will also do a C++ program, which also demonstrate how we can implement arrays in C++. So just be there and we can start now. Let's talk about arrays. Like I said, we have to understand how arrays are used. These are the objectives of this lecture. Understand how arrays are used, understand how arrays occupy the computer memory, manipulate an array and to replace the nested decisions, declare and initialize an arrays, and understand the difference between the runtime and the compile times in an array. We will also learn how to search an array for an exact match. So, what is an array? Array is a series or a list of variables in a computer memory, all of which have the same name but are differentiated with a special numbers called the subscripts. What is a subscript? A subscript is a number that indicates the position of a particular item within an array. So, when you talk about the subscript, how do we declare the arrays? Whenever you require multiple storage locations for objects, you are using a real-life counterpart of the programming array. When you declare an array, you declare a programming structure that contains multiple variables. Each variable within an array has the same name and the same data type. Each separate array variable is one element of the array. Each array element occupies an area in a memory next to or contiguous to the others as shown in figure 8.1. Okay, let's look at this picture here. So this is how arrays occupies a computer memory. So when you look at this, we have three elements which are our arrays. So given the name of an array, which is sum vals, so it simply means that at position 1 we have, at index 1 we have 25, index 2 we have 36, index 3 we have 47. So however we these things in an array. So with an arrays, the first position in an array is index 0. So that's where we start with. The array starts from 0 maybe up to infinity. So if you want an array of 10 elements, so it means that the first element will be in index 0 or position 0. So that's why the first element will be. So this is the simple explanation of an arrays. So we can also bring another explanation here. So an array is a collection of elements of the same type placed in a contiguous memory location that can be individually referenced by using index to a unique identifier. So suppose we have an array of 5 numbers. So the first number will be at index 0, index 1, index 2, index 3, and index 4. This is an array of 5 elements. So we can continue. How arrays occupy your computer memory. You indicate the number of elements an array will hold, which is the size of an array, when you declare the array along with other variables. So it means that every time when you declare you declare your arrays, you can give the size of an array. How many elements is your array going to hold? All array elements have the same group name. So if it's an array of students, it's an array of books, an array of animals, so they must have the same group name. However, each individual element has a unique subscript indicating how far away it is from the first element. So if the first element is on index 0, then the other element be in index 4. So it shows how far is that element in the index 4, how far is it from the first element, which is at index 0. So that's why they are saying the subscript, unique subscript, indicating how far it is from the first element. So here we are going to manipulate the arrays and learn to replace the nested decisions. Consider a program that keeps statistics for a recycling drive competition at a high school. The school is holding a competition between the freshman, sophomore, junior, senior classes to see which class can collect the greatest number of aluminum cans. So this is the program, the main loop or module for the recycling program. So if you look at this, we can say at this one we have a student class. So if a student class is equals to 1, yes, we say counter is equals to count 1 is equals to count 1 plus student can. If no, we check the student class. Student class is 2. Then we say count 2 is equals to count 2 plus student cans. So this is how we do it. Then this is the main loop, and we want to check now if we do the same thing using array, how are we going to implement it? So we talked about loops last week or last class. So now you understand this program. So let's jump to this one. So we are going to this main loop has been modified module. So uses the count array. So now what is happening here? We do the same thing like we did, but this time what we do, we use the arrays. So I will show you how you declare the arrays. You don't have to worry about that. So what you're going to do here, we are going to say the student class is equals to 1. Yes. So we're going to say count 1 is equals to count 1 plus student cans. So it means that an array at index 1 is equals to an array at index 1 plus the student cans. So this is how we do declare the variables, the arrays. So you use you give the array name, then this is the subscript. So it takes the index. So which position is that array that you're trying to add here? So that's how the arrays works. So I will try to demonstrate and show you how the arrays are being declared. So we come here, we check again the student class. If the student class is equals to 2, then array at index 2 is equals to count 2 plus student cans. So it means that the array at position 2, its value is going to be that array at position 2 at index 2 plus the student cans. So it will hold that value. Then we continue. So if student class is equals to 3, then we are going to say count is equals to count plus student can. So it means that array at index 3 is equals to array at index 3, which is count at index 3 plus student can. So this count, that is the array name. You need to understand that is the array name. So if I keep on using array, that is the array name. That is, it has been given the name count. So then at the end of this, you can start reading the student's record. Let's continue. The true benefit of using an array lies in your ability to use a variable as a subscript to the array, instead of using a constant such as 1 or 4. Notice in the main loop in figure 8.8 that within each decision, the value you are comparing to a student class and the constant you are using as a subscript is the resulting years process are always identical. So array declaration and initialization. Let's take a look at this. So when you declare the arrays in different programming languages, so in Basic and Visual Basic, so this is how you declare. We give it the team count, the array size, which is 30. Means this count is going to hold 30 elements. Int count is equals to 30. Then this is how you declare the arrays and initialize arrays in C++ or C hash. In Java, it's int array, then count, then is equals to new int 30. This is how you do it in Java. So in Compile, it's count occurs 30 times picture 999999. So array count 1 to 30 of an integer, that is Pascal. So each and every programming language, they have their own way of declaring the arrays. So all the declarations above have two things in common. They name the count array and indicate that there will be 30 separated numeric elements. For a flowchart or pseudocode purpose, a statement such as num count that indicates the same thing. So here has the pseudocode and the flowchart to show that this is the number. Array will hold the numeric elements, so we can use num count then subscript 30, which means that the array count, it will hold that the 30 numeric values. That's what it means. So runtime and compile time arrays. The array that you use to accumulate class counts in the can recycling program is a runtime array or execution time array, because the values that you want to use, the final can counts, are created during an actual run or execution of the program. So just get the difference. The array that you use to accumulate the class counts, that examples at the back in the can recycling program, is a runtime. So the thing is, why do we call it a runtime? But the values that you want to use, the values that you use, the final can counts are created during the actual runtime or execution of the program. So it means that if you want the final values or the final can counts, so it's being done during the execution of the program. That is the difference. Some arrays are not runtime, but rather compile time arrays. Final values are fixed at the beginning of the program, so you already know what is going to be the final values. So these ones are fixed at the beginning of the program. That is the difference between the runtime and the compile time arrays. So here is an example. Suppose you create an array with 6 elements. So if customer orders an item 307 and a clerical worker can tell whether it is valid by looking down the list and verifying that 307 is a member of the list. So we have item numbers here: 106, 108, 307, 453, 457, and 688. So here we have our arrays. So at index 1 we have 106, index 2 we have 108, index 3 we have 307, index 4 we have 405, index 5 we have 457, and index 6 we have 688. So these are the list of arrays. So what is going to happen? Searching for an exact match in an array. In a similar fashion where you can use a loop to test each valid item against the ordered item number. So it means that if the customer gives an order number or an item to order, so you are going to check within the database whether that item that the customer is trying to buy, is it available in the database. It's the same example like when you go to the shops and you want to buy something, and when you go where they put the stock and you realize that whatever that you want to buy is not there on the shelves. So you're going to go maybe to the teller and ask, do we have this kind of the product? So maybe the teller will tell you that, okay, fine, let me check in the system whether we have that item. So they are going to maybe put the reference number, then they check whether they have it maybe in the warehouse or in the storage or not. So it means that they will be having an array of items in there so that they can just start matching and see whatever the item that you're trying to look for, is it available. So to verify that an item number exists, set a subscript to 1 and set a flag variable to indicate that you have not yet determined whether the customer order is valid. So a flag variable ke yona go thusa gona ha go soka re fumana gona the item that you are trying, or the order that you are trying to search, whether eating kapa chair. So a flag is a variable that you set to indicate whether some event has occurred or not, frequently holds a true or false value. So let's consider this flowchart and pseudocode segments for finding an exact match to a customer item number. So we see here, when you look at this, so X, it has been assigned to 1. Found it, yeah, but if we are no, because so while X is less than 7, so let's remember here we had how many items? 2, 4, 6. So we have 6 items. So we are going to say while X is less than 7, if customer item number, if you give the customer item number is equals to valid item at position X, which is just the position here at index X, which is 1, then found it. It simply means that we have found such an item. Then we continue. X is equals to X plus 1. That is incrementing. X is equals to X plus 1. So we increment. We are going to check the next index. This is how we do it. So if found is equals to no, which is n, then print no such an item. It simply means that the item that we are trying to search, maybe it's not available in the list. So that is the thing. So it simply means that it will hold that simple one. Maybe we have incremented until we realize that X here is now false. Then that's where we're going to print. We don't have such an item. That is how it works. This is the flowchart. This is the pseudocode. So just understand that. So an array, this is the summary. An array is a series or a list of variables in a computer memory, all of which have the same name but are differentiated with special numbers and called the subscripts. You often can use variable as a subscript to an array, replacing multiple nested decision. An array whose values are determined during the execution of a program is a runtime array or execution time array. So those are the important. Your program should ensure that the subscript values do not go out of bounds, that is, take on a value out of a range of illegal subscripts. So I'm going to demonstrate whatsoever that you have talked about here. The actual C++ program. So when you look at this here, this is how we declare the variable, our array. So we give it a type. So it can be integer, it can be a float, or any other type, can be a string, or any other type. Then we give the name of an array here. So we use this braces, then this bracket, then we give the elements, how many elements hold array. So let's come here and look at this. So we have int FOO, then how many array elements can hold on? They are 5 array elements. So that is very important. Jwale here, to write our simple C++ program to demonstrate how arrays work. So remember, when you start writing a C++ program, you first of all, I've seen most of you still don't know how to install the compilers. So I told you that you can download any compiler that you're compatible with, but we have been using DAV C++ to do our programs in class. So you just go and download DAV C++, or you still have the latest version for DAV C++, just go and download them. So you come here, then new, you open the new project, new, then source file. You can use Control-N to do that. Then we say then we can say hash include. Now we include our header files. Remember that iostream using name base std. And then we go int main, give our main function here. You open this curly braces. Then let's declare our array. So let's give it's an int. Let's give it count, like we have been making an example count. Then let's say count is going to hold an array of 5 elements, numeric elements. Then we can use this and say, what are those elements? Maybe 12, 45, 5, 2, 3, 2, 4, 5. So we have 5 elements in our array. So remember, when you have just provided your array, it will hold how many elements. So you don't have to exit this number, because you have defined it will hold how many elements. So there is no problem when you can leave this empty when you are declaring and initializing your array. So it means that when it's like this, you can store as many elements. So the size of an array this time, when you do this, maybe it's 5 here, here it's 8. 5 is a recipe, it's 9. The 2 is a recipe, it's understand 3. Okay. So it means that the count here, it holds how many elements? 1, 2, 3, sorry. 1, 2, 3, 4, 5, 6, 7. Yeah. Now our array count in a 7 elements. So it means if you want to increase the size of it, you just keep on adding the elements. So, but let's use this whole 7 elements. Then we terminate. So suppose we want to check these elements. Take these elements within our array. So we want to get them using their indexes. Element it's on which index, which position. So we can be able to retrieve that. So like I told you that the index in the array color from the index 0. So this 12 here is at index 0. Index 1, 2, 3, 4, 5, 6. So we have 6 index. So let's see. Let's get an element of an array from all this index. So let's do C out count. We use the array name to access the elements of an array that index. So let's say 0, So now we can be able to access the elements of our array. Maybe their indexes. So let's see, array at index 0, we're going to use 0, that is count 0. So it has to output 12, that's a 1, 1, 45. In at I may output a 5, in output a 2, and so forth. So you can display and so this end line, the new line, it's going to display this arrays. It's about display and so forth and so forth. So you can and let's compile and run. See what is happening. So this is the output that we get. Array at index 0 is 12, array at index 1 45, array at index that is 2 is 5, and so forth and so forth. So that's how arrays are being manipulated. This is the simplest way. So here we have a list of arrays, a list of elements within an array. The array name is for. So here we are going to use the for loop to manipulate the contents of an array. So let's look at this. So this is our header files. We have already done that. Then we declare I as 1, that is int I. Then we have result is equals to 0. So it means that our results start from 0. Then we keep on doing sum on our array. So we are going to add the elements of an array. So how many elements do we have? We have 2, 4, 5. We have 5 elements. So we are going to add all these elements using the for loop. So we have int I, then initialize our result to 0. Then this is our main function. So simply just know that this is the main function. So when you declare the variables here, so they can be accessed anywhere within this program. So meaning they have been declared globally. But if they are declared within inside a function, that is local declaration. So now they have been declared globally, meaning they can be accessed anywhere in the program. So this is our main function. So we have the for loop. For I is equals to, remember that is I is an integer. It has been declared to an integer. It has been given the data type int. Then we say I is equals to 0 and I is less than 5, I plus plus. So we have this element. I color from 0 and I is less than 5. That is going to be 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So it means it's going to be 0, 1, 2, 3, 4. We have 5 elements. That's why it says I should be less than 5. Then I plus plus, that is incrementing I plus 1. So what is going to happen? Results. What is the result now? Result is equal to 0. So result is equals to the results, which is 0, plus foo at position I. So what is I now? I is equals to 0. So which element is at position 0 now? It's 16. So it's going to be 0 plus 16. Then result is going to store 16. Then after that, we continue, because our I is still less than 5. So we come again. We increment. That is I plus plus. So it's I is equals to 1. Then I is less than 5. Then we come here. Then what is the results now? Remember, results now is 16. Is that clear? So if you don't understand, let me repeat this. This program, we had our results which has been assigned to 0, right? And what about I? I has been initialized, just declared here. Then it has been assigned to 0 here. So what is going to happen? When I is equals to 0 and I is less than 5, result is equals to result. What is the result? Result plus foo, which is our array. This is foo is an array here that we have. which contains these elements. So foo at position I, meaning an element at position I, which is at position 0, because I is equals to 0. What is that element? It's 16. So it's going to be 0 plus 16. That is going to be 16, and it's going to be stored in the results. So then we increment. So when we increment, we say I plus 1. That means I now is going to be equals to 1, right? Then I is still less than 5. So we're going to say result, which is 16, is equals to result plus, we're going to update this result now. We're going to be result, which is 16 plus, what is the element at position I? What is I now? I is 1 plus 2. So it's going to be 16 plus 2, which is going to be 18. Then result is going to be 18. Then we increment again. So this keeps on doing that up until it reads all the elements of our array. Then it gives the output. So now, what is the end results for this program? So when you look at this, you realize that it's 147. So when you add all these elements, that is number 16 plus 2 plus 77 plus 40 plus 12, it's going to be 147. So the very same thing, we can do it in this manner. Instead of writing results is equals to result plus foo at position I, we can do results plus equals to 4. This and this are the same things. That's why when you run this, we get the same answer, which is 147. So this is how you can use the for loop to manipulate and access the contents of an array. So let's just display the elements of this array. That is, let's display the elements of this array. Let me see if okay, this is full. Okay, let me put it here. See out this full at position I. Position I. Okay, re get it now. It's the line break. Yeah. So if you look at this, you realize that here we have displayed sorry. So now if you look at this, we have our 147 in these elements when they have been added together. So here you can see we have displayed all the elements of an array, which is 16 to 77, 40 and 12. With this the C out here, C out foo, when I is equals to 0, it's going to display 16. When I is equals to 1, it's going to be 2, 77, 40 and 12. I is equals to 4. So this is how the arrays work. So I think this marks the end of our lectures.